Hello everyone, welcome to this new video. So in this today's video, we'll be solving the problem print pattern. This is an easy level question and it's the problem of the day on Geeks for Geeks. The company tags of this question are Microsoft and the topic tags are pattern printing, recursion and algorithms. Yes, this is a recursion question because we'll see that the reason. So let us go to the question now. Print a sequence of numbers starting with n without using loop. So this is the reason we are using a recursion, isn't it? Because the loop is not allowed here, using a loop is not allowed. So this is the reason we are using a recursion. So where replace n with n minus y until n greater than 0. After then replace n with n plus y until n regains its initial value. Great. So n with n minus y until n greater than 0. That means even if n equal to 0 or less than 0, you must stop. Okay. And then you need to add plus 5 and then go till the point its initial value is reached. So these are the some of the examples. We'll go through them. So expected time complexity is O of n and space complexity is O of n because we are using a recursion stack space. So in the worst case, we need to use O of n and time complexity as well. So and the constants are n goes up to 10 power 5. Great. So this is the thing. So these are the examples, n equal to 16 and n equal to 10. So if you carefully observe, just do the thing that has been asked in the question. So 16 and then when you decrease 5, you get 11, and when you decrease 5, you'll be getting 6, and when you decrease 5, you'll be getting 1, and when you decrease 5 again, you'll be getting minus 4. And now you need to rebounce, means you need to go back. So because it's been clearly mentioned, if it's less than 0 or equal to 0, you need to stop there and you need to add plus 5 now. So minus 4 plus 5 in the sense, it's 1 itself, isn't it? So it's just like this. So it will be going like in this fashion, and from 1 it will be going to 6, and from 6 it will be going to 11, and from 11 it will be going to 16. Okay, so you'll be adding first 16 and then 11 and then 6 and then 1 and then minus 4, and then once again you'll be adding 1 and then 6 and then 11 and 16. Okay, so similar is the case with 10 as well. So 10 you'll be calling on 5 because 10 this is minus 5, and then again minus 5 you'll be calling on 0, and once you have got some number that is less than or equal to 0, rebounds. Okay, so or bounce back. Okay, so you'll be adding plus 5 and you'll be getting 5, and then again plus 5 and you'll be adding 10. Okay, so this is how the recursion is. The vector is the vector elements in the vector. Great. So I hope people understood why these are the things are the outputs. Now if you carefully observe, what is the pattern that we can see clearly instructed in the question? There's some pattern, right? Pattern printing. That's the reason, because there's a pattern, they have indicated that. So what is the pattern? If you carefully observe, even if you don't carefully observe, it's very evident, to be honest. So let us consider this number, this negative number. Okay, so this negative number is acting as a mirror, isn't it? So 11, 16, 11, 6, 1, the values that you have traversed so far before reaching it will be the values after it. So 1, 6, 11, 16. So in the direction that you have come, opposite direction you'll be traveling back, and you'll be adding those values to the right side of that element. So the element that is less than 0 or equal to 0, even here in this case, this is acting as a mirror. So 10, 5, 0 and 5, 5, 10, isn't it? So 10, 5 is what you have crossed first, and you'll be traversing 5, 10, the reverse of it, just like a mirror. So it's acting like a mirror. So element less than or equal to 0 acts like a mirror. So this is what you'll be using in the recursion. This is what you'll be writing in the recursion. Great. So there is another method of solving this, like using two recursions. One recursion is for the appending those elements that are less than 0, and another is for appending for the elements greater than 0. Instead of two recursion, we can just solve it in one recursion. So how are we going to do this? This is the key point. Okay, this is the key point. Less than or equal to 0 acts like a mirror. But what can we interpret from this? So let us assume you are on this particular thing, 16. So when 16 calls the recursion machine, okay, the function that we are going to write, let us assume it as recursion machine. Okay, when 16 calls the recursion machine, it gives the output as 11. Okay, 11, it appends 11 to the vector. So let us assume this is the answer vector, and initially we have appended 16 to it. Okay, answer is 16 now. So I'll just write it properly. I'll just write it here. Answer right now it's 16, and when you call this you'll be getting 11. Okay, and this is also done. So once it's called on 11 calls on recursion machine, again recursion machine, and what is the thing that it's going to append? It will be going to append 6, right? 6 is what it's going to append. So 6, and this is also done. And now once 6, after 6, what it's going to call? Again it's going to call a recursion machine, and it's going to append 6 minus 5, that's equal to 1. So now your answer vector is like this. Okay, so once it's done, 1 will be calling the recursion machine again, rm, and now it will be appending the value of minus 4, isn't it? Minus 4 is what it's going to append. So this is what it's going to come, minus 4. And now after this, now you need to bounce back. Now you shouldn't call the recursion machine on this particular minus 9 or something, on some other element that is less than minus 4. Now you need to bounce back. So now you just return. Okay, now you just return. So after returning, what must this particular recursion machine do? This recursion machine task is not done. This recursion machine task is done, but still this is left. So now it needs to append the value that it has originally appended. It has originally appended 1. Now append the same thing, because this thing acts like a mirror. So whatever the recursion machines have been doing till now, it needs to do the same thing and then return back. So now you need to travel in this direction. Okay, so this recursion machine appends 1. Okay, appends 1 to the vector. So now your vector would be looking like this 1, and after this task is also done. This whole recursion machine task is done. Okay, now it's going to return. written back. Okay, written back. And now coming to this recursion mission, it's going to append 6. Okay, this is the original value that it has appended. Same value it will be appending now. So now your vector is going to look like this, and it's done. So it will return back. Okay, it will return back. And now coming to this particular recursion mission, it's going to append 11 because 11 is the original value that it has appended. Get. So now you'll be having this in this particular vector, answer vector, and then you'll return back. Okay, I'll just use a different thing. So you'll be returning back, and then coming to 16, you'll be appending the same value that it has originally appended. It has appended 16, so append the same value 16, and then return. So this is the main or the main function. Okay, main function. So you'll be returning back. So now your vector is going to look like this. That's it. So this is the final answer, isn't it? 16, 11, 6, 1 minus 4, 16, 11, 6 minus 4, and 1, 6, 11, 16. 1, 6, 11, 16. The answer exactly matches. So similarly, you can even write in for this case 10, 5, 0, 5, 10. Similar thing. Call your recursion mission till the point it's reaching less than or equal to 0. Once it reached, return back and append the same element because it's acting like a mirror. This point is like a mirror. Okay, this point acts like a mirror. So whatever the thing that you have covered from left to right, the same thing you're going to cover in the left, like right to left. Okay, so I hope it's clear. Let us do the same thing in the code. So instead of taking a like calling another function or defining another function with parameters n and vector, we can just declare a global variable vector in answer. Okay, so what is the task? Let us write the function first and then the base case answer dot pushback of n. Okay, and then call the recursion on n minus 5, right? N minus 5. And then because it's going to act like a vector, act like a thing, like it's going to append the same value. It's going to append the same value once this pattern n minus 5 is called successfully or completed. Okay, once this particular function is completed, n minus 5, now it's going to push the same value that it has originally appended. So answer dot pushback of n and return answer, right? And now define the base case. What is the base case? If your n it comes out to be less than or equal to 0, just add that particular value, answer dot pushback on this n minus 5. N, that's n. Okay, n, and then return answer. You'll be not be calling any further function calls from this. This is the point you'll be returning. Okay, this is the point you'll be returning, and this acts like a mirror. So whatever that you have got, like previous values, will be appended in the same order. So if n less than or equal to 0, just push that and then return answer. Great. So this must work. Okay. So there's codes in all these languages. Successful codes have been attested in the description. Go through them if you're in need of it. So I hope you people understood. If there are any doubts, please feel free to comment in the comment section. Thank you for watching. Stay tuned.